All right, college algebra, we're looking at logarithm functions, section 4.3. These are our properties, and I may just number these. This is number 1, number 2, number 3, 4, 5, 6, 7. Maybe take a screenshot of those, print them out or something so you could have them to look at as we refer to. I'll refer to these numbers as we do some of these. And but mainly what you have here, a logarithm is the inverse of an exponential. If you have 2 to the 2 to the 3 power is 8. Okay. Well, this can be written as a log. This is log base 2. See, my base of the exponent is 2, so my log base would be 2, and these numbers switch. So log base 2 of 8 is 3. All right? So if I have like 5 to the 3rd power is 125. All right, so I could write this as log base 5 of 125 equals 3. And this is the inverse of the exponential. So we can write an exponential as a log. We could write a log as an exponential. Like look, suppose I have this log base 2 of 32 is 5. Okay? I could write that as an exponential equation. My base is 2, and then the 5 comes over as the exponent to this side, and the 32 goes over to that side. And this is an exponential based on that log. Okay? But what these logs do is they help us solve exponential equations. And you have to have inverses. Like suppose you have this 2x minus 5 equals 11. Okay, you do inverses to solve this equation. So like right here, the minus 5, you do the inverse of that, which is add 5 to get rid of it. And now you have 2x equals 16. And now you got 2 times x. Well, the inverse of that is divide by 2. So you divide by 2 on both sides, which allows us to get this solution of 8. The same thing can be done if you have an exponential equation. You can do the log of it. Or if you have a log equation, you can do an exponent to solve it. But we'll get more into that later. These are the properties, though, of logs, and I'll refer to these as we do some of these problems. There's 7 of them. And like I said, maybe get a screenshot of that, or take a picture of it, or whatever. Print it out or write it down. Okay, so here we go. Here's what we're going to be looking at. Number 1, evaluate these logarithmic expressions. Right here we got log base 2 of 16. Now you can do property number 4, and you can just type this in the calculator. So like you can get your calculator here, and log base 2 of 16, you do log, and every calculator has a log button. Right here's the log. Okay. So I'm typing that in. I'll do log 16, close the parentheses up, divide by log of 2, which is 4. Okay? So the answer for that is 4. Or what you could do now, log base 2 of 16, if you realize that 16 is 2 to the 4th power, and then since these bases match, the answer is just 4. This is property number 3. This is property number 3 right here. And right here, this is property number 2 here. That's 0. Anytime you got a 1 right here, this is going to be 0. Log of any base of 1 is 0. This number right here, the 3 is called the base. The 1 is called the argument. Like you arguing. Like an argument, that's what the 1 is. So like right here, 0.1 is your argument, 10 is the base. Now on this one, like I said, you can just type that in, but this is log base 10, And then 0.1 is 10 to the negative 1 power. So that's just negative 1. Okay, scrolling on up. Right here, log base 2. The square root of 2 is 2 to the 1/2 power. So those cancel, that's 1/2. And if you don't know how to do this, if you don't know that it's 2 to the 1/2 power, you can just type it in the calculator. It's like I said, on this one, using the number 4 property, I'm going to do log of the square root of 2, okay, space out of it, parentheses, divide by log of 2. And you see there's 0.5, which is 1/2. Okay. Right here, now see this is log base e. We'll talk more about e a little bit later. But what I have here, this is 1 over e squared, which is e to the negative 2 power. I could flip it and make my exponent negative. Those cancel, that's a negative 2. You could type it in the calculator too. Log base 1/2 of 8. I think 8 can be 1/2 to the negative 3 power, I believe is what that would be. And that would be negative 3. Okay, of course you can type it in. Log of 8 divided by log of 1/2. There you go, negative 3. Okay. All right, going on to number 2, similar type stuff. All right, log base 3 of 81. The base is 3, the argument is 81. All right, I know that 81 is 3 to the 4th power, so these cancel, it's just 4. Okay. Log base 3 1/3, that's 3 to the negative 1 power, so that's negative 1. Right here, log base 10, 0.01 is 10 to the negative 2 power. These cancel, that's negative 2. And like I said, you do every one of these on the calculator, but knowing that that's 10 to the negative 2 power can simplify it, and as far as, doing it in your head. Doing it in your head is easier than punching in the calculator. And I think it's good to be able to do them in your head. This is 6 to the 1/2 power. Anytime you have a square root, that's a 1/2 power. Those cancel, that's 1/2. All right, anything to the 1 with a 1 argument is 0. Okay, now, all right, look at this one here. This one, you could probably type it in. You may not understand this, but anyway, this is log base 3. 27 is 3 to the 3rd power. So this is 3 to the 3rd power to the 3/2 power, which would be log base 3 of 3. And if I multiply these two, see this is a power of a power, so I'll multiply them. That's 9 over 2. That cancels, this 9 over 2. All right, but you can punch that in. If I punch that in, all right, I'm going to do log of 27 to the 3/2 power. Okay, get out of the exponent, put my parentheses, divide by log of base 3. And there you go, 4.5, which 9 over 2. Okay. All right, now we've got some here, like I just mentioned a while ago, write this in log form. All right, so the main thing is this is base 5, so if I write that as a log, it's going to be log of base 5. Okay. And then I'm going to have the 3125 here, and then this 5 exponent will go over here. So basically, these two numbers here swap spots. When you change from exponent to log, the base remains the same on them, but those two numbers will switch sides. Okay. right here, write this in logarithmic form. I don't like these being the same, but we got to live with it, I guess. It's going to be log base 4. Here's my base 4. And then these two numbers switch sides. So 256 comes here, 4 goes over there. Okay. Convert this to an exponential. My base is 2. And then the 4 comes on this side, 16 goes to that side. So once you get the hang of it, it's pretty easy. This would be base 4. 4 power equals x. These two here switch sides. The base is the same. Okay. Number 8. All right, we're going to graph this. All right, now, when you graph these are inverses of exponential functions. So usually on the exponent, it looks like this. This is the exponent function. Okay, a log has the tail going down, and it curls up like this, and then the asymptote is vertical on the log. Okay, so that's what the function looks like. So this is the only one that does that right here. So this would be my answer right there, B. Okay. Now they do move around. Now here's what you're looking for, and just like we had on exponential functions, you have your asymptote, and then you have your 2 points. You have those three things: the asymptote and 2 points. What are the 2 points now? On this one, they're reversed. So usually on your logarithms, on your exponents, you have 0, 1, and you have 1, whatever your base number is. In this case, is 2. This would be 1, 2. All right, but they're just switched. So this is 1, 0, and this is your base number 1. Because they're inverses, they switch them. So you got 1, 0 every time, which is this point right here, 1, 0. And then you have your base number 1, so whatever your base number is, 1 would be the other point. And then, of course, you got your asymptote. Those three things help you figure out the graph. All right, so if you look at number 9 here, number 9, all right, which of these 4 graphs is this one right here? Okay, so you can see the +2. The +2 is horizontal shift, which is going to make it go this way too. All right, so basically here, our asymptote is on the axis, so our asymptote should move over 2 like this, and then the 1, 0 that's usually right here, it should move back 2, and it should be right there, and it should look like this, which I think right here it is B. Okay. Number 10. This one we'll have to punch it in, and we'll do it just like we do on the exponentials. We'll click the graph, and we'll select the log feature, which looks like this. This is the log one. And then you got to make sure it has the base, and you got to do any shifts and stuff according to that. This one has no shift, so it's just gonna you're just gonna type the base, and there you go. You should just graph it right up. Okay. Same thing here on this one. Okay. We've got us a shift right here, +3, which is going to make it go this way 3. You got to make sure you have your base, so you'll just click the graph, and you'll select the exponential one that goes like this, and then you'll put this horizontal shift in. Okay. All right, this one has 2 shifts, so we've got this -1, which is going to go to the right 1, and then we got this +4, which is going to go up 4. And so we'll put those in on the boxes. It's a base 3. Okay. All right, now we get to this one here, number 13. Use the properties of logarithms to rewrite the expression. All right, now if you remember the properties, what do I do with that? Put it back on here real quick. Here's the properties again. Okay, we're going to be using some of these right down here is what we're going to do. what we have here is we've got a product right here, which is property number 5. So I'm going to have log base 2 of 5 plus log base 2 of y right here from this product. This is property number 5. But I'm dividing by this z here, which means I'm going to have minus log base 2 of z, which is from property number 6. And let's see here. I think that's it right there. Yeah, it says B right there, yeah. Okay. And that's just using your properties. Number 14, we're going to use our properties for this. And, all right, we're going to condense this back down. It's already spread out. But see how this is a plus and then this is a minus? So right here on this, with these are plus, we're going to use property 5 to go backwards here and put this into one log. So this is log base D, and I'm going to have x times y. Okay? But then I got minus this log of m, so I'm going to divide by it. That's from property number 6. So log base D of D, yeah, D. Okay, 15. Write this statement as an equivalent exponential form. All right, so this is easy. There's my base right there. So I'm going to have radical 3. And then the 4 comes over here as a power, and the 9 goes over there. There you go. All right. Number 16. Solve this equation. All right. So now we're going to solve this. See, my x is the base here. Okay. So x is the base. So what I can do now, I didn't show you this property, but when you have log of any base, b to this power will make it cancel off. So like if I have log of base of 5 or something, then that would just be 5. These will cancel each other. So basically on this, since this is log base x of this argument equals 4, so I can do x to this power will equal x to that power, which makes this cancel. So I have 1 over 625 equals x to the 4th. Okay? And then x to the 4th, I can do this to the 1/4 power to make this cancel, and x will equal 1 over 625 to the 1/4 power, which I think that would be 5. I think it is. Let's see here. Or 1/5. 1/5, yeah, there's the answer right there, 1/5. But I did the 4 through to 625. So 1 divided by 625, okay, to the 1/4 power. And you can see there, 1 over 5. Okay. Here, let me do this again. Okay, I'll write it here. This is log base x of 1 over 625. Let me put that in parentheses here, so it might stand a little better. So again, what I did here, since I got log base x, then x to this power should equal x to that power. And then log x to the log base x power, these cancel, and so I have 1 over 625 equals x to the 4th. Okay, that's the step there I wanted to show you again. X to this power equals x to that power. This will cancel, so I've got this equals x to the 4th. Okay, number 17, solve this one here. All right, here, I'll write it out for you. I'm going to do it again here. Log base x of 81 equals -4. So x to this power equals x to that power, since I've got base x. That makes this cancel, and 81 equals x to the -4 power. And now I can do -1/4 power of both sides to make this cancel, so x would equal 81 to the -1/4 power, which that would be 1/3, I think. think it's 1/3. Let me 81 to the negative 1/4. Oops. Yeah, I think it's 1/3. Yeah. Well, I had the answer right there. I could just looked at the answer. Okay. All right, here's one now, number 18. Choose the graph of this function right here. Choose the graph here. All right, so log base 2 of 2 over x. Okay. Now, what I have here is okay, this is log base 2 of 2, and then this x can come up, and that's x to the negative 1 power. Okay, or I can I don't know if it'd be better just doing this. Make it x over 2, all that to the negative 1 power. That's probably best if I did that, because then I can use go back to the properties. Where did I put that at? Oh my goodness. Here it is. Okay, if I go back to this one right here, number 7. See, when I have an exponent on a log, the argument of the log, I can move the exponent out front as a multiplier. Number 7 here. So that's what I'm going to do here. See, if I got this negative 1 exponent of the argument, I can put the negative 1 out front, which is just negative. And there you go. And now, since I have a negative, that's a reflection. It's a vertical reflection, which means my tail, normally it's down here. That's going to reflect it and make my tail go up here like this. So I should have, going something like this right here. And I think it looks like this one. C. Yeah, C's answer right there. See, man, you'll be good. All right, number 19. Which one of these is the correct equation for this? Now, first thing I notice, see my asymptote? It's moved over 1, 2, 3, 4. It's gone back this way 5. So that means in my parentheses here, I should have x, and then since I'm going back this way, plus 5. So it looks like B or C right here. See, they don't have plus 5 on it. Okay. The transformations are the same on every function. So you just look at your asymptote, you see it goes back that way 5, so x plus 5. All right, now, you're looking for the point that's 1 over from the asymptote, kind of like we did the exponent. On the exponent graph, we look for the point that's 1 up from the asymptote as we do the exponent, okay? Well, I look for the one that's 1 over, which is right here. And usually that point is right there. So it's gone down 1. So I should have a minus 1. Okay, these both have minus 1. Oh, look here, this is log base 2, this is log base 3. So both these have a minus 1, because see, they've both gone down 1. All right, now the way you can tell if it's base 2 or base 3, you look at the next point. Okay, and see how it's over 2 from the asymptote. So that's base 2. So the answer is B. Now if that point was over 3, then it'd be base 3. And if it was over 4 from the asymptote, it'd be base 4. Okay. Look at this one here. You got to write an equation for this one. Okay. All right. So first thing I see, the asymptote there. All right. This is going to be log. I'm not sure the base yet, but I do know this is going to be x. I'm going this way 3, so it's going to be x minus 3. Okay. I'm covering up the answer so we can't see it. Okay, now I'm looking for the point that's 1 over, which is right here. Okay, and usually it's there on the axis. Well, it's gone down 1, so I'm going to have a -1 out here. Okay, now what's my base number? Well, I look at this next point up, which is 2 over. It's going to be base 2. So that should be it right there. Right there. Lo and behold, right. Okay. Number 21. What's the equation of this one? All right, look at your asymptote. Your asymptote's 4 over. Here's my answer. I'm going to cover it up. So this is going to be log, and we're going to have x minus 4 since it's gone over to the right 4. Okay. So, all right, we'll catch this. See how the asymptote's here, but the function's going this way. So we have a negative in this thing. So we've got a negative inside here, which I think is going to turn this into a plus. This whole thing will be, I think that will turn that into a plus, I'm pretty sure. Okay, and then you look for this point right here that's 1 over from the asymptote. Okay, usually it's on the axis here, so it's going down 1, 2, 3, 4, it's going down 5. And then you look at this next point up, it's over 3, so it's got to be a base 3. So there you go. The answer is this one here, isn't it? Okay, number 22. Okay, so rewrite this. So we're going to use our properties. Okay, the properties, again, right here's our properties. And we're mainly going to use these two right here, 5 and 6. Because we got a product and a quotient. So this is going to be log base 10 of the 3 plus, since I'm multiplying these two, log base 10 of x. And then since I'm dividing by that one, I'm going to have minus log base 10 of 7. And you see my answer right there. Okay. All right, 23. All right, look here. We've got a multiplier on this one. We're wanting to condense this down to 1 log. You see my answer down there, okay? All right, well, this 4 is a multiplier in front of this log, so I can't combine these down because I got multipliers. So the multiplier has to come over as an exponent. So here's what I'm going to have first step. Log base 6 of x to the 4th power. The 4 comes over as an exponent on the x. Minus, and the same thing, the 7. The 7 goes as an exponent. So it's going to be log base 6 of y to the 7. Okay? And now, since I've got no multipliers, I can combine those. This is a minus, which means I'm going to divide these arguments. So it's going to be log base 6. I'm going to divide x to the 4th divided by y to the 7th. And there you go. There it is. Okay. Number 24. Okay, we're going to expand this out. So I've got a product and a quotient here. So this is going to be log base 4 of 7. And then plus, since I'm multiplying these, this is going to be log base 4 of the radical 3. And then this guy I'm dividing by, so it's going to be minus the log base 4 of 5. Okay, and then I see I got a radical right here, which is a 1/2 power. So if I change it to 1/2 power, that 1/2 can come out in front. So I got log base 4 of 7 plus this 1/2 can come out in front of him, and then minus log base 4 of 5. Okay, and then let's see, it says, is that what we have? Sure is. That's it. Okay. Right here on 25. Okay, use the properties here. Okay, we got us a sum in here. So 9x plus 5y. We don't have a property for this, so this can't be simplified. Okay. All right, number 26, expand this one. I'm going to cover up the answer here. I got a product, and I got two things I'm dividing by. So it's going to be like this, log base 2 of A plus log base 2 of B, and then the ones I'm dividing by minus log base 2 of C, and then minus log base 2 of D. Okay, and there you go. All right, number 27. Okay, write the expression as a single logarithm. All right, see I'm minusing those two, which means these two here I'm going to divide the arguments. They're all log base C, so log base C. This M is on top, and I'm dividing N and F. Right here, C. Yeah, C. Okay, because I'm minusing this, it's on the bottom. I'm minusing that, so F is on the bottom. 28. Okay, write the expression as a single logarithm. All right, so all right, we can't because we got a multiplier, so I got to change this multiplier to an exponent. So I've got log base A of z plus 5 to the second power plus log base A of 3z plus 6. Okay, I can't combine logs together like this with a multiplier, so I have to move it as an exponent. And now, since there's no multipliers, I can condense it down to one log base A, and I'm going to have z plus 5 squared on top. Oh, no, I'm sorry. They're both on top. I was thinking there's a minus here, so hear me write it again. Log base 2 of z plus 5 squared times 3z plus 6. So it should be that. Yeah, you see the answer right there, B. And then 29. All right, given log base 10 of 5 equals this, log base 10 of 3 equals that, find log base 10 of 15 without using a calculator. Okay. Well, here's the trick on this. Log base 10 of 15. That's going to be log base 10 of 3 times 5. Okay? And then using my properties, that's log base 10 of 3 plus log base 10 of 5. Okay? Well, it says log base 10 of 5 is this right here, 0.6990. Log base 10 of 3 is this right here, 0.4771. So I'm just going to add those two together. Okay, so if I add them, 0 plus 1 is 1, 9 plus 7 is 16, carry the 1, 10 plus 7 is 17, 1, 7 plus 4 is 11, there you go. There it is. Okay. And you can use a calculator if you have to, but I'll never know. Number 30, we're almost done. To 4 decimal places, log base 10 of 5 is this, log base 10 of 4 is that. Evaluate the logarithm log base 10 of 5/4. All right, so log base 10 of 5/4 is going to be log base 10 of 5 minus log base 10 of 4. Okay, because we're dividing those, so we're going to subtract. All right, so it says log base 10 of 5 is 0.6990 minus log base 10 of 4 is 0.6021. All right, so 0 minus 1 would be 9. 8 minus 2 would be 6. 9 minus 0 would be 9. 6 minus 6 would be 0. There you go. And then the last one here, number 31. Okay, suppose log base A of x and f of 2 is 4. Determine the function value. Okay. All right, so what we're going to have to do here is we got f of x equals log base A of x. Now watch this one, okay? It says f of 2 is 4. That means x is 2. Tells me that the f of x is 4 over here. Okay. I'm sorry. This was an A, not a 2. Sorry. made a mistake there. Okay, so log base a of 2 is 4. So that means a to this power equals a to that power. And that cancels these, so a to the 4th power equals 2. All right, so if I do a 1/4 power, this will cancel. A equals 2 to the 1/4 power. Okay, now, this right here is going to be a long decimal. So I would leave this as that. But here's my function right here. Log base 2 to the 1/4, or I tell you what, that'd be 9/4. This is 9/4. So I'll do it log of base 9/4 of x. And this is my function. Okay, log base 9/4 of x. Now it wants us to do the function value of 1/4. Okay, so there's my function now. So it wants to do f of 1/4. So I'm going to put a 1/4 right here, and so we just type that in the calculator if you want to. Okay, so I'm going to put 1/4 here for x. So as I type that in, okay, it's going to be log of 1/4. So I'm going to put 1/4 right here, divided by, well, log of 9/4. And, okay, that didn't come out right. Well, I may have made a mistake. Let's do this again. It might help to see this go through again. Okay, f of x equals log base a of x. It says f of 2 is 4, so that means when x is 2, when I got a 2 right here, this over here is 4. Okay, so a to this power equals a to that power. This cancels. So a to the 4th power equals 2. So I do a 1/4 power. And this cancels, so a equals, oh, you know what I did? That's 2 to the 1/4 power. I just have to leave it like that. That's what I did wrong. I changed it to a mixed number. That's where I made my mistake right there. I shouldn't have done that. That was 2 to the 1/4 power, and then I thought that was 2 1/4, but it's 2 to the 1/4 power. That was my mistake. I made a mistake on this. All right, so that means my function is actually this then. Function of x equals log base 2 to the 1/4 power of x. This is my function right here. Okay? And so now when I do function of 1/4, I'm going to put 1/4 for x right here, which means I'm going to type in log of 1/4 divided by log of 2 to the 1/4. Okay? All right, so let me do this now. I'm going to do log 1/4 divided by log, and I'm going to do 2 to the 1/4. And there you go, -8. This is -8. And you see the answer down there, -8's right. Okay, so the rest of these you're just going to be punching them in. So like right here, I'm going to do 8. So I'm going to put 8 right there, which means I'm going to have log of 8 divided by log of 2 to the 1/4 power. All right, so I just go back into this problem I had originally and just type me an 8 in there and delete these. And there you go, 12. This is 12. Okay, we see that right here, 12. We got 2 more. So I'm going to type 4 in, so I'm just going to go change my 8 to a 4. And that's 8. So this one's 8. You see it right there, 8. And the last one should be -2. So I'm going to type that in. So, alright, so I'm going to go back up to this. And then right here, I'm going to do square root of 2 divided by 2. So square root of 2, and I need to insert divide by 2. And there you go, negative 2. All right, so that's our lesson here. That's all the questions. You might have some problems, or you might have some, this is different, something you may not have done before. So if you have any questions, contact me and I'll help you all I can. Send me a text, a picture of your problem you're dealing with, and I'll try to explain it to you better. And anyway, have a good rest of the day.